Good day. My name is Antonio Ponte. I work as a global product manager in deposit and investment in Citibank, in the corporate investment bank. My business unit offers cash management product services for treasuries of large corporations and companies doing business around the world. One of my personal passions has been promoting and adopting emerging technologies to include it in our product and services and also for internal productivity. For example, I led the adoption of electronic signatures in Latin America in 19 countries, and also participating in projects related to blockchain, central bank digital currencies, traditional artificial intelligence, and large language models. Important disclaimer, I'm not a technology person, I'm a business person, specifically a product manager. And in the next 25 minutes, we are going to provide a framework that is going to serve as a guide discussion between business people and technology teams in how to use knowledge management using a generative AI as a foundation for the new era of enterprise, the future of work. And also, we're going to discuss the challenges to implement knowledge management using Retrieval-Augmented Generation or RAG. Another disclaimer, any views expressed by me are mine and not necessarily reflect views of the Citi of any of its affiliates. All opinions are subject to change without any notice, and the expression of opinion are not intended to be a forecast of future events or guarantee of future results. Okay, without further ado, let's enter to cover quickly the basis so we can build momentum. All this generative AI journey started almost 2 years ago with the launch of ChatGPT by OpenAI, and basically they create a ChatGPT that at human level intelligence. This is based on large language models, LLMs, and they use a technology that now not only can understand language, but also sounds, images, videos, and 3D signals, and almost any other thing that you can represent in data, or you can vectorize, compare, and learn from the patterns of these vectors. This basically opens a universe on infinite of possibilities, so you can express and manipulate the knowledge of the organization or different knowledge and create new business cases, use cases, feature, product, services, and even business models. LLMs performs an human competitive intelligence and also have the ability to create new content. That means that emulate human creativity. Today, they are so smart that, for example, in the public academic test, they are performing over average or even much better than humans, and all at the same time. That's something that humans cannot do already. One of the important points of the LLM is that are great consulting source, integrating information from various sources, and this basically create that, give them the ability as the ultimate and best knowledge integrator, information integrator that we know. The impact of the business is that basically can exponentially increase human productivity, and although this is not going to replace humans yet, can automate many tasks and list major productivity improvements and disruption in many industries. For example, let's go to what is the impact. For example, all the knowledge workers, for example, jobs that require PhD, master degrees, or college, are going to be the ones that are most disrupted. In terms of functions, we can talk about, for example, software engineer, computer science, product development, marketing, sales, customer operations, and customer service, and so on. So, but how companies are starting adopting this generative AI and element technology? Well, first, the first way is already the software that we use for our regular jobs, especially in large enterprise, okay, that takes several months to adopt technologies. The software that or years, uh, the software that we are using today are starting implementing features related to generative AI. For example, advanced chat, AI assistant, Copilot. All of those are without doing anything. The enterprise are starting getting benefits from the software that they use already. There is a next level that is basically using API for private LLMs, for example, OpenAI, that you can connect with ChatGPT and do develop using for internal productivity use cases, or also you can push that to product and services in your organization. There is another level that, for example, you can use LLMs that are open source, and you can put it in a cloud-based infrastructure, and you own that, and you can fine tune it and do a lot of things with them that reduce significantly the cost. And also, you own those. In many cases, you own that information. If you are, for example, a regulated industry that needs to preserve the data privacy, you can move from a cloud provider to a private cloud and do with those LLMs. So these are basically the most common ways, and companies, enterprise are doing all across, have different use them all at once. The enterprise expanding of generative AI and large language model is going to significantly increase during the next years. And as you see in the next graph at your right, this is going to be divided in the solutions in-house, APIs or endpoint solutions, and of course the softwares that are pushing this information, the platform that we are using every day, and it's going to be distributed in many functions, especially technology. Okay, but what is happening now? What is happening today? How people are using generative AI and knowledge management, and what is going to happen next? Well, basically today, people are companies, especially large companies, that takes months or years to adopt or and roll out and scale new technologies because of their complexity. They are starting using knowledge management and internal data to automate repetitive manual work. They are adding products and features to their services or for internal productivity, leverage these UI cases to gain huge productivity gains. Coding, content creation, translation, summarization, automation of certain tasks, operational tasks, client support, software support, those kind of things. So in the next 1 or 2 years, what is going to happen is that these companies are going to take all of these automations, and they are going to start analyzing journeys and automate the different journeys of value creation. And they are going to include high personalization using the knowledge management and internal data. And this is going to work kind of a very important complex agentic ecosystem of the agents that are going to drive automation, perform complex tasks, and even reasoning. Knowledge workers are going to start using more AI assistant tools, copilots, or chat or support, and you are going to start seeing business functions being disrupted. So software development is already happening, sales, marketing, client services, through the chat is already happening, expert advisory, and operations. And in the next 2 or 4 years, now these journeys, they are going to be important business disruption, because these journeys are going to be grouped and definitely disrupt existing business models. There are going to be more complex and autonomous agentic ecosystems. And knowledge workers, they are going to probably start seeing emerging robotics use cases and scales. And the knowledge workers definitely are going to require AI assistance. For example, we are going to learn to do our own jobs with these new tools in order to stay relevant. Actually, you can one good example for the dependence that we are going to have is the GPS. For example, myself, if I want to drive, if I want to go to point A to point B, okay, I need to use GPS. It's very difficult for me to drive without a GPS. Actually, if I'm somewhere and I want to return to my home, if I don't have GPS, I basically cannot return, or it take me several hours. So that is the level of dependencies that we are going to have knowledge workers with this technology. Okay, now how companies are implementing knowledge management using their own data. Well, that is called a technique that is retrieval-augmented generation. We know that LLMs have internal knowledge, but those internal knowledge, we cannot put the knowledge of organization and information inside LLM because everybody will have access. We need to restrict it somehow. So what the technique that has been built is that all the structured data databases in the systems and the unstructured data, documents, processes, documentation, intranet, in text, tables, images, videos, all of these repositories of information and are being vectorized and put it together in a vector database. So the user can have a query of that information. They ask a question on a command or a question specifically that is vectorized, okay, or embedded, creating an embedding that is going to search those vector databases, finding similar relevant information. That information is going to be retrieved, okay, and that is the knowledge and the context that the LLM is going to create a prompt, a special query. The RAG is going to create the question plus all this information, all of this context that is going to use the LLM to produce the answer that you need. In general terms, this is the process, and we're going to see a little bit more in the next slide. But how we can go this into production? One of the important characteristics of generative LLM is that it's very easy and simple to create prototypes. Actually, in days or weeks, a very small number of with a very small team can create a proof of concept and a prototype, and I can iterate over that. And this is basically the recommended way. So when they create a prototype robust enough, mature enough, that do what exactly is needed to be done, then is when you go to the next phase, that you try to create an app, a production application using that. And besides that is going to require a large number of engineers that are going to segment it in 3 layers. The first data layer, then the application layer, that is basically what is composed the regular application, but plus the model layer, the model pipeline that is going to manage your LLM or your model. Then once that version application is finished, you need to start monitoring and creating feedbacks to improve the performance of this generative AI application. It's important to remember that LLMs are not deterministic. They are probabilistic. You cannot determine what is going to be the results in many cases. So you need constant monitor and improve and retroalimент the model, so you ensure sure that it's delivering what you need and with the accuracy that you have. So, and that's basically the challenges that we have that we're going to discuss in this slide. What are the challenges with the RAG of the Retrieval-Augmented Generation? Well, basically the first one is data security. We need to ensure that the user access is authorized to access the correct data and the personal information is protected. Sometimes the information is irrelevant or inaccurate because there is a bad retrieval. Bad retrieval could happen because all the chunks that are retrieved or the information is not relevant, or the real relevant are not detected and retrieved. If, for example, if the chunk is too big and the information is in the middle, you can have what we call loss in the middle, and that can produce some hallucinations. Sometimes the LM model cannot synthesize properly the information because need more information, so you need to fine tuning or other techniques, or just the data is not updated because was not is outdated because was not a proper governance. And also you can have bad response because of the generation itself of the large language model due to hallucinations, irrelevance in the sense that the answer do not answer a specific question, or you can have also toxicity biases that the answer have harmful or offensive information. So, but then how we can solve those challenges in the RAG model? Well, in order to tackle this problem, we basically broke it in 5 components. The first component is going to be the data governance. The second is going to be the chunking, that we divide that information. The third is going to be, we're going to see the different components of the vectorization embeddings that we can use. Then how to see, analyze, and understand retrieval and synthesization in one chunk in order how to improve these models and the complete evaluation. Let's go into the matters. Well, but before that, it's important that you don't need to reinvent the wheel. There are software orchestration frameworks that are high-level frameworks that have pre-built components and functions that solve many of the RAG complexity problems. They manage your models, your prompt, your change agents, and of course the embeddings and the vectorization. So you don't need to reinvent the wheel. And you can use one or many depending on what you want to do. So the first challenge is RAG, data governance. The repository information, you need to have a generative AI data governance committee to create guidance and monitor them. This is super important. So you can assign regular data governance roles like data steward and data business owner to ensure that they are responsible to maintain the data relevance, they updated, and is accurate. Also, you need a very strong permissioned multi-layer approach, starting with application layer that user can have access only to certain functionalities from modules, and also a data layer that you need to organize the information classifying depending on the classification of the data and the different access group. For big organizations, you can have different RAG environment or different databases depending on the domain of the use cases, and those could be integrated at application layer. Okay, so basically you have different use cases, different functionalities, different vectors, and application level they can access as they need it. That is a very efficient way to manage all of them, to manage the different use cases and domains in the organization. And also, for a single database or single use case or vectorized database, you can use the metadata to facilitate organization, the relevance, the versioning, and the validity or the expiration of the data. But also, you can have use the metadata to classify information, confidential or personal information, and create groups of users or group of users that can have access different components of the data. This is very useful. So now let's go into the chunking. Chunking, to just to remember, is the way now we have that this information, how we are going to we need to divide it, and so in smaller components, so it's going to be more manageable, and that we can create chunks for creating this vectorization and embeddings that are going to be stored in the database. There are different ways to do that, and this chunking process significantly enhances the accuracy and the precision of the model RAG. You can do fixed chunking that is very simple to implement. It's just fixed length, but you can cut the sentences and lose the context. One of the ways to solve that is using recursive chunking that have more computational requirements, but there are small exceptions that respect the sentences of the paragraph. If you, for example, another technique is that your documents are small enough, you can use document-based chunking, or you can use semantic chunking that basically set the chunks in sentences or paragraph, or another one that is agentic chunking, that is basically you use agents to determine what type of chunk parameters or chunk technique you can use depending of the source. In terms of the best practice is to use different techniques to test different techniques depending for with your data and your processing, and also play with the parameters, okay, to see what are the ones that best suit to your use cases. In the majority of the cases, you will need to pre-process the document and start only the relevant information. Then that is basically a best practice. Or you can use also, another best practice is to use overlay chunk setups to increase the context awareness. Now, let's talk about vectorization. Vectorization refers to the process of converting text and data into numerical vectors, which are mathematical representations of machine learning models that there can be easily understand and manipulated. But that basically mathematical functions that represent vectors. For example, in this example, that you have a cat laying in front of a Christmas tree, you have the image and the text, and they are assigned together in the vector space, so they can be easily retrieval. That is basically the function. There are some techniques that we're not going to go into detail for that, but it's important that does technique vectorization have a metric for embedding latency, that is the time that to do the embedding, and also the retrieval quality. But when selecting vector databases, you need to differentiate if that is proprietary or open source, if it's the text or multimodal, the type of, if that is a dedicated vector, or if it's a SQL that have vectorization capabilities, or the features that are features that disperse of dense vectors. ChatGPT is dense vectors, and you have pre-filtering, post-filtering, re-ranking, all of that kind of thing. So this is something that you can work with your tech team. The other one is retrieval and synthesis. That is basically is in this example, when you have the query, this vector database then special index that basically refer to the proper places in the vector space, in the vector database, retrieve the relevant chunks, and we have several techniques in order to classify or manage those chunks. For example, there is ranking and the filtering that process them based on similarity scores, metadata, or just rank. You can have, for example, query transformation that take the input and refine before entering in the element. You have, for example, a chat engine that do follow-up questions and manage dialogues in certain contexts. This is great for chats. Also, you have agents that basically can perform queries in multi-documents at the same time. It's good, for example, you have, for example, you ask comparison between countries. Each of the countries is a query. retrieve it, and then comparison. And other popular technique is the response synthesizer that take the final answer and do iteration, refining the question. Another important the answer. Another important is in the retrieval synthesis is the guardrails. Guardrails are rules or controls that aim to steer and guide the model output and prevent undesired results. In other words, there are controls that prevent things going wrong. The outputs should correspond in desired moral, regulatory, compliance, legal, information security, and contextual standard of the organization. We have input guardrails that basically control the content that gets into the LLM. We have output guardrails that are validate that the LLM produce uh, uh, the information, validate that information is correct before get to the customer. Here you control oscillation using fact-check guardrails, moderation guardrails that apply the correct corporate and brand guidance, and blocking undesired answers, and syntax check. Okay, in the source list in the literature there is more information about the guardia, and this is very complex topic. And finally, we have evaluation that there are different frameworks that are going to help you to do the proper evaluations of the large language models. We are not going to go into detail into that, but it's important that in the evaluation you need to have the end-to-end evaluation. You can evaluate per chunks, or per segments. For example, evaluate retrieval, evaluate summarization in isolation. Each of the part needs to be evaluated with the proper metrics, and this metric needs to have trends over time. Well, we have finished this very high level oversight in what is knowledge management, the importance of knowledge management, and how we're going to transform the future organizations, and how this framework that was going to facilitate the discussion between product and technology about how to implement. You have here the list of the resources, and also my contact information. And thank you very much.
This was the final session of the 5th Annual NLP Summit. Thank you all very much for joining this 3-day community event and for contributing with great questions and your own experiences. During this summit, we watched over 50 sessions that span topics from open source generative AI to real-world production applications in industries like healthcare, finance, recruiting, manufacturing, and insurance. Our discussions have been guided by this year's theme, putting generative AI to work, highlighting both the potential and the challenges when getting those systems from a great idea to a reliable production software system. For those wishing to revisit sessions or catch up on the ones you missed, all content will be available on this platform on demand for the next 2 weeks. A final note of gratitude to our amazing speakers and to you, our audience, for making this one of the most engaging AI community events. Please stay connected throughout the year and have a wonderful week ahead.